So next topic is wave particle duality of matter. So duality means two. So it was first proposed by Albert Einstein. He said that he proposed dual nature and based on light photons. That means light photons have both particle character as well as wave character. So first he proposed dual nature by on light photons. So that means dual nature means light photons have both particle as well as wave character. But it was overcome by de Broglie. So this concept was extended by de Broglie, and he said any material particle has dual character of has both particle as well as wave character. So Einstein in this concept using the light photon, he said so light photons have both particle as well as wave character. And extending this concept, de Broglie said that so any material you take, it has both particle as well as wave character. So based on this, he derived the wavelength of the matter wave equation. So derive wavelength of the matter wave by using two equations. One is, so already we seen Planck's quantum hypothesis, that is E is equal to h nu. Another one is Einstein equation, E is equal to mc square. So this one is Planck's quantum hypothesis. This is Einstein mass energy equation. So this equation considered as 1, this is 2. In case of this, combining these two equations, one represents wave character and one represents particle nature. So this one is represents wave character. In case of Einstein represents particle character. By combining these two equations, we determine the wavelength of the matter wave. So combining this equation 1 and 2, so we get, by combining equation 1 and 2, we get h nu is equal to mc square. So nu frequency is nothing but velocity of light by wavelength, c by lambda. Substitute this value in this frequency equation. So h c by lambda equal to mc square. So c is common on both sides, you cancel one c. So you get an expression of lambda, h by lambda equal to mc. So we have to calculate only lambda. So the above equation become lambda is equal to h by mc. This is for photon. This equation represents wavelength of the photon. In this case, photons have zero rest mass. So in this case, photons have zero rest mass. So in case of particle means, above the equation become lambda is equal to h by mv. It is in case of particle. Previous one for photons, this one is for particle of matter. So this is all about Einstein equation. This is valid only the particle speed is less than the velocity speed of light. Always remember particle speed is less than the velocity of light. So it is valid only in this condition only. So a particle speed is less than the velocity of light. Suppose in the board exam they ask derive de Broglie equation means, so you write this two equation, E is equal to h mu and E equal to mc square. Mention this Planck's quantum hypothesis, Einstein mass energy. And in case of first equation represents wave character, second equation represents particle character. If necessary you will write, otherwise you write this equation alone. Then you mention combining this equation you get lambda is equal to h by mc in case of photons, and finally in case of particle the equation is lambda is equal to h by mv. The above equation is called as de Broglie equation. This is de Broglie equation. So always remember, suppose if they ask which one of the following is de Broglie relation equation means lambda is equal to h by mv. mv means mass into velocity, so we can represent this equation is rewritten as lambda is equal to h by p, because mass into velocity represents momentum, so we can write it as h by p. So it has one significance. In case if the mv is higher the linear momentum. So in the Bohr's postulate already I said angular momentum means mv, or if it is linear momentum means only mv. So higher the linear momentum means lesser the wavelength. Lesser the wavelength, the equation becomes insignificant. If this condition means the wavelength is insignificant, so wavelength cannot be, the equation cannot be observed. Next, suppose if lower the linear momentum means higher the wavelength. So higher the mv value means definitely denominator value becomes higher, means wavelength will be lesser, so this equation cannot be observed or considered. If the mv value is lower means definitely wavelength will be higher, so in this case the equation becomes significant. So first one the equation is insignificant because the wavelength is lesser. In case of second one the equation becomes significant. So based on this we will see one example. So in this equation, this one is significance of de Broglie example. So in this equation they mention a 6.626 kilogram iron bar moving at 10 meter per second, and second one they considering an electron moving at 72.73 meter per second. So already we know de Broglie equation means lambda is equal to h by mv. So Planck constant value constant, so already we know 6.26 into 10 power minus 34. Then the mass given as 6.626. So mass is 6.626. Velocity, that is speed. So they said moving with 10 meter per second means this one is velocity. So they given us 10 meter per second. So on substituting and cancelling, we get the value of 1 into 10 power minus 35 meter for first one. Second you try, so lambda is equal to h by mv. So in this case they mention electron. So electrons means the mass is fixed 9.1 into 10 power minus 31. So in case of mass of electron, the value is fixed. Mass of electron means 10 power 9.1 into 10 power minus 31. So we can calculate lambda is equal to, so Planck constant value already we know 6.626 into 10 power minus 34 by they mention electron, so mass of the electron is constant, so 9.1 into 10 power minus 31 into velocity they given 72.73. So on dividing you get the value of 1 into 10 power 5 meter. So consider this one is higher the mass, higher the linear momentum value, higher the mass means lower will be the wavelength. In case of yes, lower the value, so lower the linear momentum means higher will be the wavelength. So in this equation they say in this equation is significant, this is insignificant. Insignificant because for electron the wavelength is significant, for measurable. For iron balls the wavelength is too small, so it becomes insignificant. So always remember, this equation is important 5 mark question. They will ask derive de Broglie equation. Only this concept is important. They will ask in 5 mark question. In case of the significance, sometimes they will ask in 2 mark question. Suppose if they ask significance of de Broglie means higher the linear momentum, lesser the wavelength. Lower the linear momentum, higher the wavelength. It is possible in microscopic particles. Microscopic particle, that means they consider electron, because the whole concept based on electron. So microscopic particle, in terms of electron, the wavelength will be higher because mass of the electron is very less. So already we know it is 10 power minus 31 kilogram. So automatically the wavelength become larger than the size of atom. So this equation, this is the significance of de Broglie equation. Suppose if they ask the board examination, write the significance of de Broglie equation, means you have to write this. So that's all about de Broglie concept. Next we will see quantization of angular momentum under de Broglie